Welcome you all to Believers as Academy. And in this today's topic of the day discussion, we will be discussing about the NISAR satellite as a landmark, satellite launch as far as India is concerned, because this is the first ever collaboration between NASA and ISRO, making it a greatest and a big leap for India in terms of its satellite or space endeavors. So, why was it in news? We already discussed that it was recently launched from the Satish Dhawan Space Center, in Sriharikota, and this proves to be India's greatest leap into the global scale Earth monitoring. So, which we will discuss further in this particular video. Even before that, it is important to know briefly about what NISAR satellite is. As we discussed, it is a joint collaboration between NASA and ISRO. And why this? What is the purpose of the satellite? It is for the global Earth monitoring or observation, which we will see further in the video. Even before that, let's try and understand some key facts about the NISAR satellite launch. It was launched on July 30th, 2025 from the Sriharikota, which is your Satish Dhawan Space Center in Hyderabad, Andhra Pradesh, Sriharikota. And what was the launch vehicle that was used? It was the GSLV Mk2 series. Of course, it is GSLV, to be even more specific, XF16, and this is a part of your Mk2 series. So to be even more specific, it is GSLV F16, the launch vehicle. And the important point is the mission life. The mission life of the satellite is 5 years. The total cost 12,000 crore. Supposedly one of the costliest, expensive space program that India has gotten into. And what is the ultimate goal of this, of this mission? One is to get the real-time radar imaging of Earth for both scientific and also the societal uses. So this becomes very important. There are three different key terms here. One is the real-time radar imaging of the Earth, and then for what? For scientific and societal uses. Well, so now this is the basic information about the basic facts, or I can call the basic facts with respect to the NISAR satellite. Now moving on, why NISAR matters, right? So first and foremost thing, as I mentioned, that the main aim of this satellite launch was to ensure that we can get an advanced Earth observation, monitoring systems as a part of the satellites. It becomes one of the world's most advanced Earth observation satellites, not just India's, but world's. Very important. So, of course, it matters. Next is the first use of dual frequency SAR synthetic aperture radar. So now what dual frequency SAR synthetic aperture radar is? So for the very first time, they used a dual frequency SAR synthetic aperture radar. So in simple terms, if you have to understand, the satellite what we have launched, the NISAR satellite, right? The satellite which has been launched, what it does or it captures images from the Earth on a real-time basis. And this image capturing, which conventionally used to happen from cameras, is now happening through a system called as the synthetic aperture radar. So basically, radars are used for image capturing. So now what is the advantage of this? This radar, or let's say the synthetic aperture radar, is capable of capturing images in adverse climatic conditions also, even if there are too many clouds, even if there is a hailstorm, whatever be it the situation, the radar is so capable that it can capture images. And now how does the image gets captured? It's through the transfer of microwaves that hits the Earth, and then it revolves, it ripples back. So of course we're not going to go too much in detail as to what or how this process goes, but it is important to understand that it employs a technology called as the SAR technology, the synthetic aperture radar, which is not of the conventional camera way of taking the images where cameras were used, but this is where radars are used. Okay, and what is the key advantage of this? It enables to capture images even in any climatic conditions, or even you can get more precise images, more detailed observations can be achieved from this system. That is what you have to understand. And what is dual frequency? Dual frequency, which we will study later, basically talks about employing two different bands. One is the L band, another one is the S band, which we will discuss further. So for the first time, this NISAR satellite has used dual frequency SAR, the synthetic aperture radar. Hence, it becomes important. And what it does with the help of these L band and S band, it helps to track or take the images or record or store data with respect to land deformation, crop patterns, disaster management, and even more, right? It even supports climate monitoring, natural disaster responses, and agriculture. So how are these things happening? It is due to the L band and the S band, because if you have to simply understand what L band and S band is, it's like they are the eyes of the satellite. It is like the eye, they're like the eyes of the satellite, like the S band and the L band, which helps the satellite to scan, to take information. What are the informations it is taking? It is tracking land deformation, crop patterns, and also going further, it even tracks climate monitoring, natural disasters. Of course, specifically L band captures few things, specifically S band captures few things, which we will discuss further, right? So this is the reason why this becomes very important, NISAR satellite, because there are a lot of first time thing here. It's one of the world's most advanced Earth observation satellites. Plus, this is the first ever collaboration of India, with US, that is the NASA and ISRO. And then it is the first use of dual frequency SAR. So obviously this becomes important, right? Now, what are the key technical features of this satellite NISAR? One is, it is part of your sun synchronous polar orbit. So now, what is sun synchronous polar orbit? We have, one is the geostationary orbit, right? And then we have the sun synchronous orbit, and also we have low Earth orbit, right? There are three different types of orbits on which satellites move. Of course, sun synchronous orbit is a part of your low Earth orbit. So what is geostationary orbit? Simply, if we have to take an example, if this is the Earth, north, south. So this is the geostationary orbit. And what is the distance? The distance of this orbit from Earth is roughly 35,786 kilometers. So this is the geostationary orbit, where the satellite moves, in a horizontal fashion, right? Probably from the east to west, right? Or the, you're getting the point? East to west. And now, what about the low Earth orbit? It is the same path, it is the same orbit, but the distance of the satellite from the Earth is somewhere between 600 to 800 kilometers. So this is to track, minute details, small imagings, to capture small images, or let's say to even capture small, minute details. So this is the satellite they use. And then, what about the sun synchronizing orbit? So this is that orbit. Now, if this is the Earth, now here in the geostationary and the low Earth, the orbit or the satellite orbits in a horizontal fashion, but here it orbits from north to south. So the satellite orbits from north to south. So this is how the rotation of the satellite goes. So basically, the NISAR satellite is a part of your sun synchronous polar orbit. So now, why it is a part of sun synchronous polar orbit? Because we also studied that NISAR satellite, in the first place, it is used as, used for what? Observing the Earth. And now, when the satellite rotates or moves, around the Earth, and also how the Earth revolves, right? So it ensures that it captures each and every movement of the Earth from the North Pole till the South Pole. And now just imagine if the NISAR satellite was here. So it could possibly, only track the images of the equator or the subtropics or the tropics. So what about the polar regions here? Absolutely nothing, right? So hence the orbit of the NISAR satellite is the sun synchronous. Because why? Because it is the part of, or the main aim of this satellite is to track Earth details. For the help of observing the Earth, we need data. So that is the reason why we have put it in the sun synchronous. I hope this much is clear. And what is another important feature? The antenna. It uses a 12-meter antenna. Antenna basically means the radar, right? What we discussed. And what is the radar swath? 240 kilometer. Swath simply means the if this is the Earth, and if let's say the satellite is here, what is the width of the Earth that the satellite or the radar can capture? Okay, in one spin, right? So that is the radar swath. And what is it? It says 240. It means in one spin of the satellite in the sun synchronous orbit, it captures the data of 240 kilometer, right? So some satellites even does it for 20 kilometers also, which means the efficiency is very less. Now this captures 240, which means 240 kilometer coverage of the Earth with every movement is something exceptional. And what is the resolution? 3 to 10 meters spatial, right? Which means as minute as the movement of, let's say, to give you a simple understanding, even or let's say, what were the uses of the NISAR satellite? We said it can be also helpful for the agriculture use, to study crop patterns. Means now you understand what this term is, the resolution, right? So it can capture as minute as crop patterns also, right? The movement of cars, study the infrastructure, the urban infrastructure or rural infrastructure, right? So we will study further. And then the revisit time. It takes 12 days to completely get the data of the entire globe and give it. So that is what it says. But how much time does it take to complete one spin of the Earth? It is 97 minutes. One spin of the Earth, it does in 97 minutes, but it takes 12 days to give the data of the entire globe, because 97 minutes it goes one round, simultaneously Earth is also rotating and revolving, and then now we also have to simultaneously imagine that after every 97 minutes the satellite takes another turn, right? So in total it takes 12 days to give the information globally. Simple. Now we discussed about what the SAR technology is. So here we will slightly go in detail. Of course, I mentioned that these are the two eyes of the satellite. One is the L band and the S band. So this is the first ever introduction. We have introduced both of this band, and very important key thing to know that the L band we have gotten it from NASA, and the S band is our own from the ISRO. And what does L band do? L band is that frequency which kind of goes little bit in depth. Okay, it does in-depth analysis of what? It tracks, soils, forests, right? Let's say the soil patterns. So now let's say if a satellite, the frequency is able to understand soil patterns, you can understand how in-depth, the frequency goes, how in-depth the study goes, right? So it helps us track the soil patterns. Even for that matter, it helps us understand tectonic plates to study earthquakes, right? Even maybe for that matter, volcanoes, correct? And even for that matter, it can even track ice sheet melting also, the ice melting, correct? So all of these things is done by what? The L band, which is, scanning things from a very in-depth level, right? And then we have the ISRO's S band, which of course is not as in-depth as the L band, but it is a surface level monitoring frequency where it tracks the crops, water levels, vegetation, urban infrastructure, etc. Hope this is clear. And what is the advantage of this? We can get all weather details, including day and night data, including those data even when there is cloud, smog, right? Even the details with respect to vegetation, all the details, right? So now this becomes very important because this is that satellite which gives us the data of everything and anything with respect to the world in a all weather situation. Now, how is this possible? It is possible because it uses the SAR technology and not the conventional camera imaging system where it uses cameras to take the images. Right? So now moving to the major applications. We discussed, it helps us in getting information with respect to earthquakes, landslides, subsidence. It also helps us track information, to get, the information on forest health, biomass, biodiversity. It also helps us in understanding the glacier movements, polar ice thickness, or even, the melting of polar, the snow sheets. And it also helps us understand the erosion activities, especially the coastal zones, right? The receding of the coastal areas, or understanding the pattern of the coastal movements with respect to erosions, oil spills, storm surges, right? Everything. And even it is even more important that it can send signal, and it can even map the damage maps within 5 hours with respect to disasters also, right? So that timely responses, timely aids can be provided to those areas where a disaster is hit. And most importantly, it can be used for agriculture and infrastructure development also. Why? Because it also helps for us to get information on crop health, dam and road. So now this is obviously very important, these points, for the mains perspective. If there is a question about the integration of science in the day-to-day life, the present relevance, these are the feeders, the pointers that you can use, by also mentioning NISAR satellite, and this becomes a very great point for your means answer writing as well. Moving forward, so we discussed what is the India specific enhancements that is there in the NISAR satellite. One is the S-band operation, correct, over Indian territory. For what? The S-band, I think it is very clear. S-band is from the ISRO, the India, right? So now, why is it important, or what does it track? It is tailored, as it is channelized to track the biomass and soil moisture mapping. We can use it for agriculture forecasting, disaster management, ionospheric correction, for high precision imaging, right? So we're talking about the satellite here, right? I hope it is clear. Then another important thing to keep in mind is the open data policy. So just because it is a collaboration between USA and India, as a part of your NASA and ISRO mission, doesn't mean the data that it collects is only restricted to India and US. No. So it comes under the open data policy. It is a part of the open data policy where the data that is captured by NISAR satellite is available globally, right? It is available globally and everybody can use it, right? So that is one thing. And this we have studied what are the contributions of NASA and ISRO. Just if you want, you can just have a look at it. The L-band frequency is the radar from the NASA, and the ISRO is the S-band radar, and the 12-meter radar is from the NASA. The satellite bus is India's, and then the antenna structure KS band, and even the launch vehicle GSLV. So I think this is pretty much clear. So this of course makes very important. So satellite, because the launch as to what it gives to India, like what is the moment for India after this launch. Satellite assembled and tested in Bangalore, right? So this is another important thing. It was launched from Sriharikota, very important, but it was satellite, it was assembled, tested in Bangalore, right? So obviously it becomes very important. And then it is the made in India satellite for global use. That is also another important reason and another pride moment for India, that it kind of pushes the Make in India scheme, the Make in India agenda of the government also. And then it is a symbol of India-US scientific partnership, very important, and it aligns India's goals in rural development, sustainable agriculture, disaster resilience, climate adaptation. Means any topic from the mains, or even for that matter essay with respect to these topics, you can use it, right? So that becomes a very good information also for the mains examination. So at the end, we have to understand that NISAR is a game changer in earth science, and disaster preparedness. It's not just for your scientific purpose that we have launched this NISAR satellite, but for also the social use that we discussed in the first slide the moment we started the video, because it also helps the society to be absolutely prepared for any disaster, even be it natural disaster, crop related disaster, anything and everything is covered in this NISAR satellite. And it shows the power of international collaboration, because it talks about India and USA, which is the NASA and the ISRO, right, for solving global challenges. And at the end, we have to also make sure to understand that this helps India emerge as a key player in cutting edge satellite technology as well, right? So that's all for today's video. I hope what satellite, the NISAR satellite is absolutely clear. So for more such informative content like this, please do subscribe to Believers YouTube channel. And signing off, this is Madan Gopal. Have a beautiful day.